Hi, I'm Dr. Ian Van Loosen from the Department of Mathematics and Statistics at Curtin University. Let's say I want to solve a triangle which is a non-right angle triangle, just as we have here. To solve a triangle such as this, we need to use either the sine rule or the cosine rule, depending on what information is given to us. Let's start by looking at the sine rule. We use the sine rule whenever we're given a triangle with two angles and any given side, or two sides and any angle which is not enclosed by them. So for a general triangle ABC, the law of sines tells us that a side length is proportional to the sine of its opposite angle. So stated mathematically, we have A divided by the sine of its opposite angle A must equal to side length B divided by the sine of its opposite angle B equals to side length C divided by the sine of its opposite angle C. The sine rule, as we can see, is made up of three equations. To solve for a triangle, we don't need to use all three equations. So let's go back to our earlier example. So here we can see in this case, we have a triangle, we're given two side lengths and an angle which is not enclosed by these two side lengths. So we can solve this by using the sine rule. So we're given side length A and this opposite angle capital A, we're given side length little b. So the first thing we can calculate is the angle at B. So from the sine rule says A divided by sine of A equals to B divided by sine of B. Putting in our given information, side length A divided by the sine of its opposite angle, which is 21 degrees, equals to side length B divided by the sine of its opposite angle, capital B. So making sine B the subject of our equation, what we'll do is multiply both sides by the sine of B, multiply both sides by the sine of 21 degrees, and we'll also divide through by 14. So we get sine of B is equal to 17 times by the sine of 21 degrees divided by 14. Evaluating this on our calculator, we get the following value. Now solving for this angle B from our calculator, we simply take the sine inverse of our value, 0.43. And our calculator will give us the angle of 25.8 degrees. But in this case, we need to be a little bit careful because there is a second possible solution at this angle B. That is, to get our second solution, from 180 degrees, we subtract away that previous angle. And that will give us 154.20 degrees. This is a second possible angle that we can have in this triangle. The reason being, if we look at the graph of the sine function between 0 and 180 degrees, there's always going to be two angles which are going to give us the same constant value. For here, if I take the sine of 25.8 degrees and the sine of 154.2 degrees, they're both going to give me the same constant value of 0.43. What does this second angle tell us? Well, simply due to limited information that was given to us, there's going to be two distinct triangles which fit the given description. In a practical problem, you might actually be able to discount one of these angles. Also, this is only a second possible solution, provided when we add it to the angles that we already have in our triangle, it add up to less than 180 degrees. Here, if I add 154 degrees to 21 degrees, I get 175 degrees, which is less than 180 degrees. So this is a second possible solution. So therefore, in this example, here we'll pursue both cases. So, starting with our first case, where the angle at B was equal to 25.8 degrees. So now we have two angles in our triangle. To determine that last angle in our triangle at C, all the angles in the triangle add up to 180 degrees. So 180 degrees, subtract away those two angles that I already have, gives me my remaining angle at C. So now I have all the angles in the triangle. The one bit of information I still haven't yet found is the side length C. To work out the side length C, again I can use the sine rule. So the sine rule tells us that A divided by sine of A must equal to the side length C divided by the sine of its opposite angle. So again, if we put in the information that we know, A 14 divided by the sine of its opposite angle must equal to this side length C divided by the sine of its opposite angle, which we just calculated to be 133.2 degrees. Now, making this C the subject of the equation, I'll just multiply both sides by that sine of 133 degrees. So evaluating this gives us our side length at little c. So here we solved our triangle using the case when the angle at B is equal to 25.8 degrees. Now let's look at the other case. So in our case 2 is where our angle at B was equal to 154.2 degrees. So again, like last time, we have two angles in our triangle. I've got one remaining angle to work out at C. So subtracting these two angles from 180 degrees, will tell me that the angle at C is equal to 4.8. So once again, the last bit of information we have to determine is their side length little c. So we'll apply sine rule once more. So the sine rule tells us A divided by sine of A must equal to C divided by sine of C. Again, putting in our given information, side length A 14 divided by the sine of its opposite angle must equal to the side length C divided by the sine of its opposite angle, which we just worked out. Making C the subject of the equation, multiply both sides by the sine of 4.8 degrees. Evaluating this on our calculator gives us our side length at little c. So here we solved the triangle in the second case where the angle at B was equal to 154.2 degrees. So in summary, we use the law of sines if we're given a triangle where we have two side lengths and an angle which is not enclosed between the two sides, or we're given at least two angles and one side. However, we can't use the sine rule if we were given a triangle with all side lengths but no angles, or we're given a triangle with two side lengths and the angle enclosed between the side lengths. In situations such as these, we need to use the cosine rule. Thanks for watching.